Dear all, today we are going to understand how to draw shear force and bending diagram for a simply supported beam with overhang on both sides, and the whole span is loaded with a uniformly distributed load and a moment at the mid span as shown in this diagram. And here in this particular numerical problem, a simply supported beam having span length 6 meter, and it can be seen that simply supported portion is having 4 meter length and 1 meter overhang on both sides. As well as this beam is loaded with a uniformly distributed load of intensity 4 kilonewton per meter throughout the span of the beam, including the overhang, and a moment of 8 kilonewton meter is acting at the mid span of the beam. Now we will be going to learn that how to draw shear force and bend diagram for this type of numerical problem. So first of all, we have to calculate the support reaction. So you can see in this diagram, there are two support reaction RB and RD. And after solving, we are getting the value RB is equal to 10 kilonewton and RD is equal to 14 kilonewton. So here, considering the beam as loaded with the UDL and as we have discussed that a moment is also applied, and this beam is under the static equilibrium, and applying the conditions of static equilibrium, that means equations of static equilibrium, summation Fy, that means sum of the forces along the y direction, is equal to 0, that means vertical direction, and sum of the moment about any simple support, that is either B or D, and making it equal to 0. From both these equations, we will be easily can find out the reactions at B and D. So taking summation of forces along y direction equal to 0, and taking calculation from the whole span, that is span A to E, and from starting from A to E, if we move from A to B, then we can get this equation. That means whole span length is 2 to 4 plus 1 plus 1, that means total 6 meter. So load will be, downward load will be 4 into 6 meter minus we have taken since it is acting vertically downward, and both the reactions RB and RD, they are acting vertically upward, so we have taken them positive. So minus 24 plus RB plus RD, making it equal to 0, we can get this equation RB plus RD is equal to 24 kilonewton. Now second equation we can develop by taking moment about support B equal to 0. So first of all, we will be taking the moment of the load acting on the overhang AB, and this overhang, this load, since it is acting downward, and it will create a movement in the anti-clockwise direction. So to calculate, first of all, we will be calculating 4 into 1 meter is the overhang. 4 into 1 into 0.5, it will give you the movement about support B, and due to this is UDL, and the negative sign we have taken since it is an anti-clockwise movement. Then another span, that means 2 plus 2 4 plus 1, that means span length from B to E, that we can consider in a one go, that means, and calculating the force. So that force comes out to be 4 into 5 meter, and it will be acting at the mid span BE, and to take the moment from B, we will get the distance between the centroid of the load and support B, that is 2.5. And third one is the movement which is acting 8 kilonewton meter, so it is acting clockwise, so we are again taking it positive. And the last one is the RT, that is the reaction at support D. So it will be giving anti-clockwise movement when this movement is taken off the force, that is RT reaction 14 kilonewton about B. So it will be anti-clockwise. So we have taken it negative. So this is the way we can develop this equation. And after simplifying, we are getting RD is equal to 14 kilonewton. So from equation A and B, ultimately, we can get RB is equal to 10 kilonewton and RD is equal to 14 kilonewton. Now, in the next step, we have to solve for the the numerical problem that is for shear force. So first of all, we have to develop shear force equations, and again we take appropriate section as we have discussed in the previous numericals also. So by taking section between, we can take section between D and D, then between CD or between DB. And for shear force, we can take only three sections: section between DE, and a section between BD, and a section between BA. So let us consider, and let us take a section XX as shown here, red color section, at a distance x from farthest end, that is at E. So first of all, we will develop the shear force equation between E and D. So it's very simple. Shear force equation, that means shear force at any section x which is at a distance x from E. So that will be only UDL, and this UDL is acting on span length x. So 4 into x will give you the value of the shear force, and since it is having x raised to power 1 only, degree 1, so it is a linear equation. So based on this equation and putting the various values, because this equation is applicable between E and D. So when we have to calculate shear force at E, we can put the value of x equal to 0. So we are getting shear force at E is equal to 0. Then shear force at D, or we can say just a right of D, we can put the value of x equal to 1 meter. So we are getting 4 into 1, that is 4 kilometer. And then shear force at just left of D, when we take into consideration a section just left of D, then this RD, that is equal to 14 kilonewton, will also come into calculation. So it is plus 4 minus 14, so it comes out to be minus 10 kilonewton. So now how to draw the shear force diagram, let us understand. And in this equation, since it is a linear equation and it is applicable between E and D, so an inclined line between E and just right of D, that means where shear force is plus 4 kilonewton, increasing from 0 to 4 kilonewton. So the shear force diagram between E and D will be an inclined line because it is load is a UDL, and we are well aware when load is in the form of a uniformly distributed load, then shear force diagram will be an inclined line. And after that, exactly just left of D, and we are getting minus 10 kilonewton. So minus 10 kilonewton mean plus 4 to minus 10, there will be a vertical drop. So a vertical drop in shear force at D up to minus 10 kilonewton due to vertical reaction. So two things we can learn here, that is first of all, shear force diagram between any two sections of the beam where only UDL is acting, it will be an inclined line, and wherever any vertical load is acting, so then there may be vertical drop or vertical rise depending on the direction of the load. Now let us consider another section, the portion between B and D. So shear force equation again we can develop by taking any section at a distance x from E. So again we are getting, first of all, UDL is acting there, and due to that UDL, 4 into x will be the vertically downward load, and minus 14 it will be acting the vertically upward. So this equation we can develop, again it is also a linear equation. So based on the section where you take, that means this equation is applicable between D and B. So we can get the shear force at D by putting x equal to 0. So you are getting x equal to 0 or x equal to okay. So when you have to calculate shear force at D, then only x will be 1 meter. So when you put the 1 meter here, 4 into 1, that is plus 4 minus 14 minus 10. So minus 10 kilonewton. And similarly, when we are going to calculate shear force just right of B, that means we have to put the value of x this much, that is 2 plus 2, 4 plus 1, 5, then you will get plus 6 kilonewton shear force just right of B. And similarly, just left of B, then this 10 kilonewton will also come into picture. So plus 6 minus 10, that is minus 4 kilonewton. And we are well aware that shear force at A will be 0. So based on all these values, we can easily draw the shear force diagram. And you can see here, first of all, shear force. This will be the reference line, and on this reference line, first of all, we will take the point E. That means section at E where shear force is 0. Then after that, shear force just left of just right of D will be +4, and then -10. So this will be the variation in the shear force. So we can draw the diagram in such a way that means 0 to +4, +4 to -10, -10 to +6, then -4 and 0. So this is the way how to draw the shear force diagram. Now in step number 3, we have to draw the bending moment diagram. So how to draw bending moment diagram, how to develop bending moment equation. So that's a detail we will be going to understand in this particular step. So first of all, again, we have to take various sections. Now you can see here, we have divided the portion between D and B into two parts, DC and CV. Since at C you can find additional moment is acting. So we have to take section accordingly. So let us first of all, again, similar to the shear force diagram, we can take this section XX which is at a distance X from E. So first of all, we will consider the portion ED, and we can develop the bending moment equation. Since only vertically downward load is acting, and this vertically downward load, when apply moment about XX, that means if it will apply bending moment about XX, so it will be giving a hogging moment. So shape of the beam, elastic shape of the beam will be hogging type. So bending moment will be taken as negative. So distance is x meter from E to that section under consideration. So first of all, -4 into x and into x by 2. So you can see here x raised to power 2 will come when you solve this equation. So it is a parabolic equation. So based on this, we can easily calculate the bending moment. Bending moment at A, E is equal to 0, and bending moment at D, just a right of D, when you put x equal to 1. So when you put here x equal to 1, you are getting -2 kilonewton meter. That is the bending moment value, just right of D. Okay, so now how to draw the bending moment diagram? So it is a parabolic. So parabolic curve between E and just right of D, varying from 0 to -2 kilonewton meter. Now when we have to take the portion DC, so then we will be considering that this section has been shifted between D and C, and the distance of this section will be x from farthest and E. So then based on this, we can easily develop this equation 4 into x by 2, and then this 14 kilonewton will also come into picture when you take section somewhere here. So this 14 into x minus 1. So this 14 into x minus 1. Again, it is having highest degrees 2 of x. That means it is a parabolic equation. So based on this equation, we can find out bending moment at D as well as bending moment at C. So first of all, bending moment D, it will come out to -2 kilonewton meter. And bending moment at C, since there is a movement is also acting. So first of all, when we consider any section just right of C, then this movement will not come into picture. So just right of C, bending moment is +10 kilonewton meter. And when we consider any section just left of the C, then this 8 kilonewton meter movement will also need to be taken into consideration. So +10 minus 8, so it comes out to be +2 kilonewton meter. So here we have calculated bending moment at E will be 0, bending moment at D will be -2 kilonewton meter, bending moment just right of C will be 10 kilonewton meter positive, and the bending moment at just left of C will be +2 kilonewton meter. So now how to draw the bending moment diagram? So it is again a parabolic curve between D and just a right of C. So that means between D, section D and the section just a right of C, and its value will be changing from -2 kilonewton meter to +10 kilonewton meter. And after that, since you can see here bending moment at C, that means it's at a section just left of C somewhere here, then it will give you the bending moment value +2 kilonewton meter. So that means there will be a vertical drop from +10 kilonewton meter at a section just right of C, and +2 kilonewton meter just at section at a left of C. So then another portion is CB, and we have to take a section between C and B similar to the previous steps, and we can get the bending moment equation. So this will be also parabolic equation, and we can easily get the bending moment at C, that is +2 kilonewton meter, bending moment B after putting the value of x. So then you get -2 kilonewton meter, and bending moment at A will be 0. So based on this, first of all, we have to locate all the points 0 kilonewton, -2 kilonewton, etc. So first of all, it is a parabolic equation, parabolic curve between this E and D. Then from D to just right of C. Then from at a point just at a section just left of C. Then at a section B, that is -2 kilonewton. Again, it is a parabolic curve. And after that, movement bending moment at A is 0. So this equation is a straight line equation. So because you will get here when you take any section, so it is just a parabolic, not straight line. It is a parabolic curve. So this parabolic curve, here it is parabolic curve, here it is parabolic curve, vertical drop, parabolic, and a parabolic curve. So this is the way how we have to draw shear force and bending moment diagram for a simply supported beam along with overhang loaded with UDL as well as having some movement. Thank you.